So the sheet I pulled had a little bit of everything. So remember, this is factored form. 9 out of 10 times, if they ask you to write the polynomial, this is not the form they want it in. You have to get to this form to be able to write the final polynomial, but all the math part is what they need to see as well. This for in behavior, just because we're here, both of these are going down. That means we have a even exponent for sure, because they're same. The right side is going down, so that leading coefficient is definitely going to be negative. And I'm not sure you can see it on my screen, but there is a negative right here in the front, and that will be that leading coefficient that would turn this, in this case, quadratic parabola down. Increasing to decreasing. This is our axis of symmetry, obviously, for quadratics, if you remember that from Math 1 or 2. We're increasing on the right-hand side, decreasing on the left-hand side. Again, that's as you're reading from right to left, not what direction it's facing. So don't let increase and decrease get mixed up with in behavior. So increase to decrease is going to always be domains. So x values only. So it's increasing from negative infinity. You can use parentheses, not brackets. That's from this side. All the way till we get to -2. And then from -2 to positive infinity, to all the way to the right, it's decreasing, going down. So miniature domains for increasing and decreasing, x values only. I'm sorry. Then to write this in behavior statement, that was the other thing I wanted to do on these guys. Sorry. So as x approaches positive infinity, that means as I look right, y, or f of x, is going to approach negative infinity, because that's at the end. As x approaches negative infinity, that means as I look left from like the origin over here, f of x or y is going to approach, again, negative infinity. If you can, if this is giving you some trouble still, this part is written the same every single time. The only part that's up for debate are those last two inequalities if you use this outline every time. So if you want to make this your always, and if you want to switch out f of x for y, that's fine too. Just remember that they are the same thing. This is non-negotiable. I have to look right. I have to look left. These are where the option is for you to fill in. Like sort of the fill in the blanks are back here at the end. Here and here. Writing this polynomial, because it's given to us in factored form, so I have -1 times x minus 1 times x plus 5. Now, you can do this when it's binomial like this. You can do it by FOIL or box method. Most all of these are going to be binomial, so you will have that FOIL choice or box method choice. But what I like to do is make sure I check off each one, because sometimes they get really long. It's a lot of commitment to the math. It's where most people mess up. It's just you have to do so much math. And we're used to being able to rush through things and get an answer. If you rush through this puppy, you will miss it. And again, it will definitely be on your EOC. So x times x is x squared. -1 times x is a -1x. 5 times x, 5x. 5 times -1, -5. You guys are okay with what I did right there to get those numbers, like as far as box method is concerned, like multiplying the two binomials, or no? Because I can go back and explain that a little bit more where those numbers came from if we need to. Perfect. So this is my first binomial, so I took care of this one. This is my second binomial, so I took care of this one. The only thing left is that -1. Which is just going to change the symbols of everything through. So -x squared minus 4x plus 5 is our answer to this problem for the polynomial not in factored form. What I like to tell people is that as long as you will see where your mistakes are if you do enough of these. And if it happens to be in the math part and it's like a positive or a negative, or you combine like terms incorrectly, or you just make some silly mistake, you can sometimes catch that by putting the first one as given in Desmos, and then put your answer choice, like what you think the answer is, in line number 2. And as always, they should graph on top of each other. All right, so I'm going to skip over to the third one just for conversation's sake, for EOC and review. So in behavior is where, increase and decrease is going to be kind of messy on that, guy, so we're going to let it go because there's not good turn points. In behavior, as x approaches the right, y is going to go where? As x approaches the left, y is going to go where? Again, that's your non-negotiable. You have to do that part. So as I look to the right, y is going up. And as I look to the left, y is also going up. So again, this is going to have an even exponent because they're the same, and a positive leading coefficient because the right is going up. Even, so I have 2. This is a multiplicity of 2 because that's squared, 3, and 4, which means it went 1, 2, 3, 4. Those are the relationship between those. Now, these are the factors again. Can't say this enough. Factors. Looking at your zeros, that means I have a 0 at -1, which came from this guy. So my zeros, or my roots is the other word, and they use them equally interchangeably, would be a -1. We have a +2. We see it bounce in the graph, and we also see the 2 exponent in the factor form. So that +2, that -1 is a multiplicity of 1. The 2 is a multiplicity of 2. And then our +4 is a multiplicity of 1. And you know it's a 1 because it crossed through the x-axis and kept going. And because from the factored form, there is no exponent. Multiplicity of 2 just means it's raised to the second power. A lot of students, when they see it written in this format, which is what the EOC release question is. Sorry, my dog's having a tantrum, if you can hear him. Multiplicity of 2 does not mean like 2 and 2. Like I said, -1 multiplicity of 2, the roots are not -1 and 2, if that was the notation. Your roots are just these guys. And then that means that factor is going to be written. So that's the factor for -1. That's the factor for that +2. And they wrote it squared, which is the most simplified form. But when we get to writing our actual polynomial, you'll need to write it twice. And then last but not least, the x -4 because of that +4 root. Now, here's the fun part. There's no way of getting around this and making this any shorter, faster, or any of those fantastic things. We just have to work through and multiply them all the way through. So I have x + 1, x - 2. Again, we're going to work through. And I think for most students, what I would say is that this is hard because, again, the long-term commitment to doing it and staying neat and staying in the game, because there's not a faster way to get to your answer. So x times x is x squared, 1 times x is 1x, x times -2 is -2x, and 1 times the -2 is a -2. So now I've taken care of this guy and this guy, and I end up with x squared minus x, because -2 and +1, minus 2. Still have math to do. So this is a 3 by 2. This is why I like box method, because these puppies get kind of big sometimes. And they are not holding back on the EOC, I can assure you. So now I'm taking care of this guy. He's going right here. And as x squared times x gives me x to the third power. X squared times -2 is a -2x squared. X times a -x is a -x squared. -x times a -2 gives me that +2x, because a negative and a negative. -2 times x, -2x. -2 times -2 is a +4. Now here, if anyone's missing, like in this case, it's 2, 1, none. So it should always be on the diagonals. If for some reason, when you cleaned out one of these boxes, it got rid of some guy, like in line, like we talked about, if everybody's there when we're dividing, then your diagonals are going to be messed up. So I think in math 1 and math 2, typically when you're doing the diagonals, 9 times out of 10, they always match up. So just to call out that to make sure you're not just jumping too fast, that they do match. So we have x to the third. Negative 2x squared and negative x squared. These guys match, so it's minus 3x cubed. These guys do cancel each other out. If I have 2, I lost 2. So this is a perfect example of what I'm talking about. Oop, I put a 3 on that one, and it should be a 2. This guy should be a 2. And then we lost our x1, and we end up with a 4. So this will be the perfect example to show you what I was talking about. We're still not done because we've only taken care of 3 of them. Another 3 by 2 box. We got x minus 4. Now we're taking care of the last one, and our final answer should come from this box. X times x to the third power is x to the fourth power. X to the third times a negative 4 is a negative 4x to the third. Negative 3x squared times x is a negative 3x cubed. Negative 3x squared times a negative 4, that's negative 3 and negative 4, which is going to give us a positive 12x squared. 4 times x is 4x, and 4 times a negative 4 is going to give us a negative 16. Now, our final answer is x to the fourth. This guy will always be a Lone Ranger with your highest exponent as long as everything is in largest to smallest numbers, or if it's in standard form. This guy is an x to the third, negative 4 and negative 3 gives me a negative 7, x to the third power. These two guys do not match. They are not like terms. This is an x squared, this is an x, and that's because that one guy up here was missing. If you want to put it in here as well when you're multiplying into the box, just like we did multiplying out of the box, it won't mess anything up. Just know you'll never see a 0 in front of a variable in your final answer. So then at that point, I just had that positive 12x squared, positive 4x, and then minus 16. That long puppy should be your answer. Again, if you plug this into Desmos and this into Desmos in the second line, they should graph on top of each other. It's the best way to make sure you're correct. A question yet? All right, lovely. So I'm going to skip this one for the most part, except setting up the factor part just to make sure. Positive 1, so the y is we'd write x equals 1 and x equals negative 4. We got to get it set equal to 0, so we're going to move this way, and it's going to be x minus 1 equals 0. That is now my factor, and that negative 4 is going to come over, and that's going to be x plus 4 equals 0, and that's my factor. So what you would then multiply is x minus 1 times x plus 4. And I think for the most part, the multiplication part is not where the knowing how to do it is not the problem. It's getting through it without making mistakes. So I'm going to skip the box method on this guy. That's a binomial, whole numbers, no multiplicity issues. They are both happening one time because there's no notation of it happening more than one time. In my best practice of watching students, our problem comes with fractions, and then again, like I said, multiplicity. So in this case, I have a positive 2, multiplicity of 3. That does not mean I'm going to use that 3. That just means that that 2 is going to happen 3 times. And then I have a 0, and then I have a 3/4. And I don't know what it is about 3/4. I think we're not listening to me. It takes you a little while for me to get it through. For some people, the fractions are not hard. They're just different. It's not quite as easy. You can't jump as fast. So we're going to move that 2 over, and we have x minus 2 as that factor. Again, multiplicity of 3 means it is going to happen 3 times. It's a lot of multiplication we get to do. So ultimately from here, 3, 1, 1, this is going to have a degree of 5 when we're done in the very front. The 0, if I move it over, x minus 0, that means this factor is just going to be an x. 3/4. Now, your choice. You can use operations, because then to get rid of the division of 4, we're going to multiply by 4, which gives me 4x equals 3. Then we're going to move that 3 over, and it's 4x minus 3 as my factor. That is absolutely, completely, and utterly the most beautiful math-backed way to do this. In my silly brain, as you guys well know, I've made up stuff. So x equals 3 over 4. So in my mind, 4 jumps in the front and 3 gets in the back opposite. So 4x minus 3 equals 0. Like, I don't do it this way. And this is where I've started from math 1 on. A lot of our mental math is actual like math, like mathy math. It's just the wording and how we describe it is different. So I like the guy on the bottom jumps, attaches to the x opposite of who's on top is your factor here. And again, at this point, you're going to multiply one set of boxes with x minus 2, x minus 2. That's going to give you a trinomial. And we're still not even out of the x minus 2s yet, because then you're going to do x minus 2 again with your trinomial that came out of this box here. Then you're going to have a 4, because we just added another x to it. I don't usually use this guy next because I can do that one pretty easily just by distributing it through. So box method, the next one would be 4x minus 3 with your 4-term polynomial from this box across the top. Still not done. Then we're going to distribute our x all the way through. Do you guys want to see this multiplication all the way through? Or are you okay and vaguely understand that concept and want to set up the last one real quick? Okay, we're just going to set up the last one. Because again, like I said, I think the bigger problem is typically the setup, not the actual multiplication. Or I should say the biggest thing that I can teach. The actual multiplication is just a matter of, like I said, staying invested. So a negative 1/2, 0, and 1/4. This is a multiplicity of 2. So I got to make sure that this guy happens twice. Multiplicity of 2 means this is going to happen twice. Like I said, I like to do 2 jumps in the front, opposite of the top. So 2x plus 1. X equals 0 is just going to give me an x when I'm done. And then again, 4 is going to jump in the top. Top guy's going to come opposite. 4x minus 1. This is multiplicity of 2. So it happens twice. Again, you're going to multiply your binomials. So 2x plus 1. And then I'm going to go ahead and grab one of my binomials instead of just the x. Take care of that guy. So I'm going to end up with a trinomial, which I'm going to put along the top. And then I'm going to put my extra binomial here. Multiply that through. And then our last x all the way through whatever we get out of these boxes. And then you end up with your answer. I had somebody call me out and tell me they didn't know what that was. An arrow. Equal marks. All right, for the sake of your time.